to be able to understand the content of the video, it is recommended to look up artificial gravity. I'm not going to explain the principle too much here. This is an artificial gravity simulation experiment where I simulate gravity through the centrifugal force generated by a high-speed rotating track. The acceleration of gravity on Mars is 0.38 times the acceleration of gravity on Earth, which is 3.74. So theoretically, only an acceleration of more than 3.72 for needs to be simulated by centrifugal force. And the object will not fall at the highest point, and the artificial acceleration of gravity realized by this device is 9.85, so the object will not fall. It's worth noting that I slowed the game down for ease of observation. Normally 20 seconds for the device to make a turn is not easy to observe. Slowing down the game time does not affect the actual physical effects. Here you can see that the object is completely at its highest point, not falling and not touching the baffle below. It is the centrifugal force that is holding the object tightly against the baffle behind it, showing that artificial gravity can be achieved. For the sake of rigor, I next reduced the speed of the device so that it would provide only 0.1 grams of gravitational acceleration. Since it is less than the gravitational acceleration of Mars, the object will fall at a high point. Okay, I've now turned down the unit so that it only provides 0.98 acceleration, much smaller than Mars 3.74. If the in-game physics are correct, the player should be able to see the object sliding out of the baffle at a high point to drop down. I put two objects this time, one inside a container surrounded by a baffle and one on a baffle. Two objects can be seen sliding down at the same time, proving that the physical effect is correct. Thanks for watching.